This is Professor Pelton. This is part 2 of Chapter 3, Section 7. Okay, so if you want to find the inverse function, whatever function that you have, just replace the y with f of x. If it's written in function notation, write it in equation notation. That's step 1, right? It doesn't have to be y, but x and y are typically used. Interchange the variables, so just basically switch the x and the y, and then basically solve for y. Okay. If the function has an inverse, then y will be defined as a singular function, right? Not all functions have an inverse, okay, as you'll see coming up in the next section. And then state the domain and range of the original function and the inverse function. Okay, let's try 3 different variations down here, and I'll have you try 3. Okay, so we're going to write this in equation notation first. So y equals, oh boy, I don't know what happened there. Let's try this again. This is y, come on, y equals 7x minus 5, right? This is the original. So this is the original. So we're going to take the original equation, not the function notation, and switch the x and the y. So x equals 7y minus 5. Okay, so we'll add 5 to the side. So we have x plus 5 equals 7y. Then we'll divide by 7. So basically we get x plus 5 over 7 equals y. Okay, so essentially if I rewrite this, f inverse of x is x plus 5 over 7. Okay, because the notation needs to be changed back to a function notation essentially. Okay. All right, so the original domain and range, so domain and range. And the inverse domain and range we'll put down here, domain and range. Okay, so this is a linear function. There's no restrictions on what I can plug into the original, so it's negative infinity to infinity. Okay, there's no restrictions as to what I can plug into that x, whether it's positive, negative, or 0. So that gives me the range of this also. Okay, because the domain of the function is the range of the inverse. Okay, and conversely, the range of the function is the domain of the inverse, and there's no restrictions as to what I can plug into here. I can plug a positive number, a negative number, a 0, doesn't matter. So that is my domain here. So as a result, that's my range here, which makes sense. It's a line going in both directions infinitely, so it goes forever up, forever down, forever left, forever right. Okay, so let's try the next one. So if I rewrite this in equation format, I get y equals 3 over x plus 2. So that's my original, right? The original function. So I'll rewrite it with the x equals 3 over y plus 2. Okay, you rewrite it when you switch x and y. I'm going to cross multiply, so I'll put that over 1 so I can cross multiply and get x times y plus 2 equals 3, right? So I'm cross multiplying. So I'll divide by the x, so I get y plus 2 equals 3 over x. Then I'll subtract 2, so I get y equals 3 over x minus 2. So if I write that in function notation, the inverse of f is 3 over x minus 2. Okay, so if I do domain and range of the original, domain and range, I get down here to the inverse and I write domain and range. Okay, so there's one of 2 ways to do these. Figure out the domain and range of the original, flip them for the inverse, or you can go back and forth, whichever one you find is easier. So if I look at the original, I am not going to be able to plug in a negative 2. If I do that, I get a 0 on the bottom. You cannot divide by 0. So my domain is negative infinity to negative 2, union negative 2 to infinity. Okay, so I have a domain restriction. So that is my range of my inverse, which is negative infinity to negative 2, union negative 2 to infinity. Okay, so range, I can either figure out that from the original, or I can figure out the domain of the inverse. So if I look at the inverse, I cannot plug in 0 because I can't do 3 divided by 0. So that is negative infinity to 0, union 0 to infinity. Okay, which is in fact our range of the original function, negative infinity to 0, union 0 to infinity. Okay. All right, and you can prove that to yourself as to why. All right. So essentially, no matter what I plug into this function, right, no matter what I plug in, I can never get 0 as an output, right? Because if you plug in 0, you get 3 over 2. If you plug in negative 2, you get 3 over 0, which can't be done. So you never get 0, essentially. Okay. You think about down here, this 3 over x can never be 0, right? It can be close to 0, but never get there. So basically, I'm approaching the negative 2, but I never get there, essentially. I'm always a little bit more, a little bit less than negative 2. All right, and you can graph those to prove that to yourself, that that's what the domain and range is, each of those. Okay, so let's do the inverse of the next one. So y equals 2 plus root x plus 4, or minus 4, excuse me. Okay, so that's the original. So let's write domain and range on the sign here. So domain and range. Okay, so we'll switch. So x equals 2 plus root x minus 4. Oh, y. Sorry, y. Forgot about the whole switching variable part. Y minus 4. Okay, so I'm going to subtract 2 to the other side. So I have x minus 2 equals root y minus 4. So I'm going to square both sides. So I get x minus 2 squared minus the square root of y minus 4 squared. So I'm just going to keep the x minus 2 the way it is. I'm not going to multiply it out, and I'm just going to get y minus 4 on this side because the square and the square root cancel. So I get x minus 2 squared plus 4 equals y. So essentially, f inverse of x is equal to x minus 2 squared plus 4. Okay. All right. So down here we will put domain and range. So we'll put domain here, and we'll put range here. Okay. So if you look at the inverse function, there's nothing I can't plug into there, right? All right. Let's look at the domain and range of the original, though. So the original has a problem because I cannot do a square root of a negative. So the lowest number I can plug into there is a 4. Anything less than 4 will result in a negative. So I have to plug in 4 or greater, right? So as a result, that is the range of my inverse function, which will be 4 or greater. Okay. All right, so again, I can get the range of my original or the domain of my inverse. That'll be the same answer essentially. Okay. So let's think about the range. So the lowest number I can plug in is a 4 into the x. So if I plug a 4 into there, that makes the square root 0. So that means that this will just result in a 2 answer if the radical is 0, because the radical can never be negative, can only be positive, right? So it's 2 plus a positive number. So the lowest number I can be is 2 as far as my range. So that is the domain of my inverse. Okay, and again, you can work both ways. You can work from inverse to original, or from original to inverse. It's up to you, and play it out to yourself in your mind, right? So if the lowest number I can plug into here is a 2, right? then that's going to give you a 0, which results in an output of a 4, doesn't it? Which makes sense to our range. All right, pause the video, try the student problems for yourself. Okay, so the next one, we're going to write it in equation notation. So y equals 4x to the third minus 1, so that's our original. And we'll write domain and range over here. So domain and range for the original. And then down here, we'll calculate the inverse function. So let's see here. X equals 4 y to the third minus 1. So add 1 to the side. So we have x plus 1 equals 4y to the third. Then we'll divide by 4. So x plus 1 over 4 equals y to the third. So now we'll need to do a third root. So the third root of x plus 1 over 4 equals, crap, leave enough room there. The third root of y to the third, all right? So essentially my inverse is f inverse of x equals the third root of x plus 1 over 4. There we go. All right, so we'll write domain and we'll write range. Okay, so if I look at the original, it's a third power. There's nothing I can plug into there. It's going to give me any problems. There's no denominators. There's no even roots. There's no trigonometry. So it's negative infinity to infinity, right? There's no restrictions as to what I plug into that x whatsoever. So that is my range of this one. Okay, so if I think in here, what can I not plug in? Well, it's a third root, right? There's no restrictions on what you can third root. You can third root negatives, you can third root positives, because it's not a root. You can also third root zeros. So there's no restrictions as to what I can plug into here. That's typically how I go about them. What can I plug in? What's my restrictions as to what I can plug in? And I look for trigonometry, denominators, even radicals, things like that. So there's nothing like that. So that, in fact, is my range here, because one gives you the other. Okay, let's go to the next one. So we'll rewrite this. So y equals 5 over x plus 4. So that is the original. So domain and range of the original. Okay, so we'll flip the variable. So x equals 5 over y plus 4. So I'll subtract 4 to the side. So I get x minus 4 equals 5 over y. Then I'm going to multiply by y on both sides. So I'll get y times x minus 4 equals 5 over y times y, right? So those will cancel on the right side. So I'll divide by the x minus 4. So y times x minus 4 equals 5. So I'll divide by x minus 4. Divide by x minus 4. So y equals 5 over x minus 4. So that is my inverse function. Okay. All right, so we'll write domain and range over here. So domain and range. Okay, so again, you can approach it from either one. You can approach it from the original or from the inverse. So we'll look at the inverse first. I cannot plug in 0 into there, because if I do, I'm dividing by 0. So anything else I can plug in there, positive or negative numbers. So negative infinity to 0, union 0 to infinity is the domain there. So as a result, that is the range here, negative infinity to 0, union 0 to infinity. Okay, so I can think about what is the outcome here. Well, if I think about the outcome here, right, this fraction 5 over x can never be 0. It's always something a little more, a little less than 0, right? So as a result, I'm basically 4 plus or minus some number, right? Or I can approach it from down here, looking at the inverse, and I cannot plug in 4 into there. If I plug in 4, I'm dividing by 0. So my domain is negative infinity to 4 union 4. Oh, that's supposed to be a comma. I don't know why the comma went up there. 4 to infinity, right? So from either way, I can determine the range and domain by looking at either one. It gives you the same outcome. Okay, all right, last one. So y equals 2 minus root x. Let's shift that over a little bit. I don't know why that happened like that. So y equals 2 minus root x. So there's our original. And we'll figure out the domain and the range. Okay, so we'll switch the variables and we'll get x equals 2 minus root y, excuse me. All right, so I'll subtract 2, so I have x minus 2 equals negative root y. I'll divide by negative 1, so I get 2 minus x equals root y. Then I'll square both sides, so I have 2 minus x squared equals root y squared. So thus 2 minus x squared equals y. Thus the inverse of x, f of x, is 2 minus x squared. Okay, then we'll write domain and range over here. So domain and range of the inverse. Okay, so the original one, what can I not plug in? Well, I cannot plug in anything that's negative. I can plug in 0, square root of 0 is just fine, right? So I get 0 included to infinity. I can plug that in. Just can't plug in any negatives, right? So that is the range of my outcome. It is 0 to infinity. Put a box there and that there, which kind of makes sense. Can you think about it? The inverse is squaring, so I cannot get a negative answer on the outcome. No matter what I plug in here for x, right, the outcome is always a positive outcome because of the square. The lowest answer you can get is a 0 for the outcome, right, which is range. All right, so we can think about the domain here. I can plug basically anything into the inverse, right? There's no restrictions as to positives or negatives. However, the range outcome here, right, the biggest this is going to be is 0 or a positive number, right? Or a positive number. And then I have a 2. So it's 2 minus a number, basically, right? So the biggest that number is a 0. Otherwise, it's a negative outcome, right? Because this square root here is always going to be a positive. So it's 2 minus 0 or 2 minus a positive number. So the biggest you're ever going to be is a 2, right? And then it's going to go down to negative infinity. Okay, so that would be our input here is negative infinity to 2. That is not writing correctly. I don't know why. Negative infinity to 2. Okay. Okay. That is the end of part 2.